Hi, my name is Grant Stokey, and this is my demonstration of homemade supercapacitors made for MAE 535 design of electromechanical systems at NC State University.
I suppose a good starting place is to describe what exactly is a supercapacitor. Well, traditional capacitors are widespread in the electronics that we use daily, and they're useful for their ability to store energy in an electrical field. A capacitor's capacitance, which is measured in farads, is the charge stored in coulombs divided by the voltage. Because of this calculation, farads are quite a large unit, so traditional capacitors are often measured on the scale of microfarads. Many modern supercapacitors are called electric double-layer capacitors, in which ions in an electrolyte interact with oppositely charged carbon-covered electrodes to provide a capacitance. The carbon coating here serves to increase the surface area of the electrodes. To demonstrate the effectiveness of this technique, let's first take a look at the performance of a traditional parallel plate capacitor.
Alright, so to build our homemade parallel plate capacitor, I've got some materials laying in front of me here. To start with, I have two aluminum plates. I have a strip of regular old printer paper for my dielectric. I've got 4 bag clips here, a couple of copper wires, and some leads here attached to my multimeter. And I also have here for my power supply an AC adapter that has DC output with 5 volts and 180 milliamps. So now to test my homemade parallel plate capacitor, I'm simply going to attach the power supply for a few seconds. We're attached, so let's count to 10. Our capacitor is essentially charged. And now I'll attach my leads for my voltmeter and we'll see how this thing performs. So as you can see, it jumped up to 20 some odd millivolts for a few seconds there, and it's gradually decreasing back towards 0. So to build our homemade supercapacitor, I've got some additional supplies laid out in front of me here. To start with, we have some activated carbon. This is just bought at the pet store. This is carbon for a fish filter. And with that, I've taken that up, put it in a coffee grinder and ground it up to pulverize it into a real fine powder. And I also have here, to make my electrolyte, I have some Epsom salt and some glycerin. And I've made a mixture here. It's about 8 parts of glycerin to 1 part by volume of Epsom salt. And it took a couple of days for this to dissolve. So now I've effectively saturated my paper separator with the glycerin and Epsom salt electrolyte. So I'm going to do similar to what I did last time with my regular old traditional parallel plate capacitor. So I found that I needed to give my supercapacitor a little time to kind of come to equilibrium and for all the parts to settle down. But once I've done so, it does indeed seem to show a big improvement over our traditional parallel plate capacitor. So I'm going to do the same thing I did last time to test it out. I'm just going to attach the power supply for a short time. And disconnect the power supply. And this time we should see a big spike.
After repeated trials, I found that the maximum voltage across the supercapacitor was, on average, about 10 times greater than the voltage across the traditional capacitor. Measured capacitance was also several orders of magnitude greater with the supercapacitor, and the supercap discharge produced a measurable current, whereas the traditional capacitor did not. Thanks for watching.